Okay, in this video I will prove this property of the central force field, like the total energy of the particle moving in a central force field is conserved. We know that the total energy, which I represent by E, is the sum of both kinetic energy plus potential energy. Now kinetic energy we discussed before is equal to half mv square, but here we replace mass by the effective mass or reduced mass times velocity square, and we represent the potential energy by this v, which is a function of position vector. So the total energy will be equal to 1 over 2 mu v square plus v of r. This v basically represent the potential energy, not the velocity. There is a difference. This is the capital V and this is the smaller v. Now velocity is basically, we did in the plane polar coordinate system, which is r dot into r unit vector plus r theta dot into theta unit vector. If we calculate the dot product of velocity with itself, we get v square, and this v square is taking the dot product of this one, we get r dot square plus r square theta dot square. So using this value back in this equation, we get energy, total energy, which is 1 over 2 mu r dot square plus r square theta dot square plus v of r, the potential energy. If we expand this one, we get 1 over 2 mu r dot square plus 1 over 2 mu r square theta dot square plus v of r. Now angular momentum is, we calculate the value for the angular momentum, which is 1 over mu r square theta dot. If we calculate its square, we get mu square r4 theta dot square. So 1 over 2 mu r dot square plus 1 over 2, I will multiply and divide this part by mu r square. So here we have mu square r4 theta dot square over mu r square. If I simplify, I will get this relation back plus v of r. E is equal to the total energy of the particle in a central force field is equal to 1 over 2 mu r dot square plus, now this is L square by this, so we have L square over 2 mu r square plus v of r, the potential energy. This is the expression for the total energy in plane polar coordinate systems. Now we will move to the central force field again. The central force F of r is basically equal to the mass times acceleration, but this is the radial force, so the acceleration will be radial acceleration. Radial acceleration will be equal to force times mass, which is the reduced mass, and we know that the value for the radial acceleration is r double dot ar is equal to r double dot minus r theta dot square. So using this value here, we get r double dot minus r theta dot square is equal to f of r over mu. Now bring this mu to this side, we get mu r double dot minus mu r theta dot square is equal to f of r. Also we know that the negative gradient of potential, negative gradient of potential is equal to the force. Or we can say that F of R is equal to minus delta V. Or we can write as F of R is equal to minus dV over dr. So here we have mu R double dot minus mu R theta dot square is equal to minus dV over dr. This implies that mu R double dot minus, I will divide this equation by mu R cube, this part by mu R cube, and also multiply it by mu R cube. So we have mu square R4 theta dot square, which is equal to minus dV over dr. Now angular momentum L is mu R square theta dot, and L square is equal to mu square R4 theta dot square. So using this value here, we have mu R double dot minus L square over mu R cube is equal to minus dV over dr, where V is the potential energy. Or we can write mu R double dot is equal to minus dV over dr plus L square over mu R cube. This will be equal to minus dV over dr, and we have minus d over dr of L square over mu R square, 2 mu R square, sorry. If we apply this differential operator d over dr on this one, we get this relation back. We can write mu R double dot is equal to d over dr, so we can keep it outside, minus d over dr, and we have potential energy plus L square over 2 mu R square. Now we have multiply throughout by R dot by R dot. So we have mu R dot R double dot is equal to minus R dot d over dr V plus L square over 2 mu R square. Now this is minus R dot is basically dr over dt. So we have dr over dt into d over dr into V plus L square over 2 mu R square. Now dr cancel with this dr, so mu R dot into R double dot is now equal to minus d over dt of V plus L square over 2 mu R square. And also this can be written as d over dt of 1 over 2 mu R dot square. If we expand this by applying this operator d over dt, we get this relation again, because I will do it here. I will do it here. D over dt of 1 over 2 mu R dot square is equal to 1 over 2, mu is constant, so we have d over dt of R dot square. So this is 1 over 2 mu, and we have 2 R dot into R double dot. 2 cancel with this one, so we left with mu R dot R double dot, which is this one. is equal to minus d over dt of v plus L square over 2 mu r square. I bring this factor to this side. We have d over dt of 1 over 2 mu r dot square plus d over dt of v plus L square over mu r square. We can write this is equal to this d over dt of 1 over 2 mu r dot square plus v plus L square over mu r square, which is equal to 0. This is equal to 0. So we can write this in this form. This implies that d over dt of 1 over 2 mu r dot square plus L square over mu r square plus v r is equal to 0. And we also define energy here. The total energy is 1 over 2 mu r dot, which is 1 over 2 mu r dot plus L square over 2 mu r square plus L square over 2 mu r square. Yes, this is 2 mu r square. Yeah, 2 is here. So this is 2 mu r square. So this is 2 mu r square. So again here we have 2 mu r square. So we have this L square or 2 mu r square, which is this one, and plus v of r, which is this one. So replace this term by total energy, we get dE over dt, which is equal to 0. Or dE is equal to 0 into dt. Integrating, we get E is equal to constant. And this is the third property of central force field. So we proved 3 properties of central force field. The first property is the force field is the central force is conservative. In other words, the total energy of a particle moving in a central force field is constant, which we prove here. The second property we prove is the total angular momentum. The angular momentum is conserved. What it means? It means that the total angular momentum of a particle moving in a central force field is also constant. And the third property is that the motion is planar. The motion is planar. In the next video, we will discuss few other aspects of central force field. Thank you.